What we want to do to be able to do questions like this one on the board is we need to know how to, well, you can do it in the run matrix mode, but a better way to do it, in my honest opinion, is to do it in the graphing mode. So we'll load up the graphing mode and we're presented with y equals. Now, we're not dealing with y equals, are we? We're dealing with these guys here. We're dealing with vector equations. This what's it's a line in vector form. What we're going to do is firstly we're going to break it into parametric form. X equals 1 plus 3t, y equals 9 plus minus 4t. Does that make sense? So to do this, we're going to go into type and we're going to go param, and that will put us in parametric mode. Next we key in the values. X equals 1 plus 3t. And then the next one, don't do that. The next one is going to be y equals 9 plus minus 4t. Okay, now depending on how your calculator is set up and who's used the parametric form last, it's going to do anything. So we can graph it, it'll literally do anything, nothing useful there. So what we're going to do is we're going to set up the V window. Usually before you hit draw on this, you have to have an idea of what it is you're looking at. So we're going to go Shift, V window. Now, the context of the question is that T stands for time and time starts at 0. So what do you, T stands for time and it starts at 0. So what we need to do is we need to go down to the very bottom and we're dealing with T, theta min, max and pitch. Firstly, what is the smallest value of T we're interested in? 0. What do you think our largest value of T we're interested in will be? 3. So let's just go 4. Okay, now pitch tells us if we start at 0, how many increments do you want to count up by? Yeah, ones. So you can go something like, just go the difference. So we'll go like 4 divided by, let's just say we want 100 markers along the way. Done. Actually, no, let's go more. 4 divided by 1,000 markers. The more markers you have, the slower it is to actually plot these. Okay, that's done. Next thing we need to think about is what will be our lowest value of x, given the situation.
Zero.
X equals 1 plus 3t. Just 1, and y is going to decrease because it's a negative gradient. We'll deal with that after. So let's go, 0 will be fine because it starts at 1. How high up will it get? T equals 4, 12, 13, so let's just go 14 to fit it all in. Scale doesn't matter. Now for the y values, we do the same. We start at 9 and we're decreasing, so let's go 10 as our max. And then for our min, you can just have a stab if you want. 37?
Negative 37. It's probably a bit off.
That's alright. When I did it on my small calculator, I just went whack and did it really wide. Fix it up later. But yeah, you can do it like that. Hit, plop, and booyah, there's your thingy. Now if you want to change it, notice that you're all the way up here. Let's just change that min to negative 10. Try again. That looks better. Now the question is, we want to be able to pull values away from this. So plot the path for object t equals 0, 1, 2, 3. Here's where the calculator makes a lot of sense to use. we can go G-solve, whoops, not that one. We can go G-solve, we can go across, and then you've got YCal and XCal. Just go YCal, T equals 1, so 1 second in, it'll tell you your X and Y locations. How cool is that?
What if you just V-window automatic?
It doesn't work very well in parametric. Yeah. So we're just using the 2D version of parametric at the moment. You will have to use 3D stuff in the future, but we won't be using it on this feature. In fact, we won't really do anything useful on a calculator in 3D parametric. Pretty cool stuff, right?
Pretty sick.
Yeah, this is an intro for your final topic, DEs, differential equations.